Let's see if this thing can do donuts. Hell yeah. A few weeks ago I found a little remote controlled car whilst cleaning up, but this was unlike any remote controlled car I'd ever seen. The remote was wired straight to the car. It had two levers, forwards and backwards, that was all. The big idea was to take this car and convert it so that it would work with a wireless remote control. I had no idea what the inside looked like, so first thing I did was to take it apart. The shell came off first, an old Ford Ranger shell. Then took a few screws off and started having a closer look at the insides. There's the pinion gear that came off the motor, two gears to try and increase the torque, and the gear on the drive axle. So it quickly started to seem like a pretty easy project. I had recently bought a wrong size motor for another project that fit this project perfectly. I removed the pinion gear off the old brushed motor and slid it onto the new motor. I later added some thread locker to hold the pinion gear on more solidly. To make the motor fit, I had to remove some plastic. After I was able to make it fit snug, I drilled some holes and zip tied the motor to the body. I screwed everything back into place, connected the electronic speed controller to the receiver and motor, and tested it. Next, I had to find a way to be able to turn the wheels, and as if this car was purposely made for this, there was already a bar set in place for me to use. I took advantage of this, drilled a hole in the bar, and cut a little bit off the cover for the arm of the servo to turn. After the turning and the acceleration seemed to work smoothly, I hot glued the servo on so it didn't budge. I also used double-sided tape to hold the receiver and the ESC to the body. I made a hole in the shell to run the wires for the battery outside so the battery could be stored on top of the shell. I soon discovered two pretty crucial things. The little car was pretty horrible off-road, especially compared to its full-scale counterpart. And secondly, placing the battery on top of the shell increased the center of gravity so drastically it was almost impossible to actually drive the car. As soon as you gave it a little bit of throttle, it would instantly topple over. I decided to remove the shell for the time being in order to properly test the car. After playing around with it for a while, I noticed the flipping over issue seemed to disappear somewhat. On acceleration, it didn't flip, but once it gained some speed, it would roll when turning. So I decided it needed some upgrades. I also wanted to use a shell again to preserve the look of the original car. So here are a few clips of me explaining the changes that I'd made. Before you watch these clips, I wanted to make a quick apology about the loud crows in the background. Yeah, the aim of this experiment was to be able to turn the wheels without them locking up at this point right here. So when they would turn, they would lock up right here. So in order to do that, the wheels needed to move away from this point right here. So the plan, let's get the servo out of the way. The plan was to elongate this part right here, and let's say extend the front right here. So it wouldn't touch over here, and also be able to more precisely place the servo in a manner that turned the wheels more efficiently, and the wheels had a lot of movement in them, so I wanted to eliminate that as well. So what I designed was this bad boy right here. Now there's two pieces to it. There's the main piece, which joins right onto here. The holes need to match up. Currently they do not, because I need to cut off that little tooth right there. and I will attach it with these screws right here. So that one will go there, and it will be extended by about maybe 3-4 centimeters. Then in this space right here, I will need to put the wheels right into here so they turn freely, and then put that into there. There you go, close to perfect. Now looking at it, I can see that when turning it, it does lock onto here as well, so we're kind of taking a step backwards. And as you can see here, the servo, these little blocks right here were supposed to hold the servo. It was supposed to connect onto this, so the servo was supposed to fit right in between those two bad boys, but as you can see, hopefully, they are too close together, so they don't fit, and they are much too far away, so the steering arm doesn't even reach. So in this case, I could either make a hole into there so I can reach these, because those little hooks right there is what will be used to turn it, and they seem to line up exactly where the servo arm should be. Let's see if I can get a good angle. So the servo should be connected right there, and the servo arm seems to line up very nicely. That's all thanks to my designing skills. So in this case, I could possibly remove a square from here, take a chunk out of here, and have this almost like a C. And I think with a little bit of drill work, you could get those to work. The screws that I'd be using with this one, that I took into account, when designing this, were these. They're about 14 millimeters long, and they fit about that much into the extension, I guess. So I guess overall, there was some certain parts to it that weren't really thought of. The printing came out absolutely perfectly. I increased the infill by about 10% with this, so it's very solid, because this car is very quick. So now one problem with this car, when it used to have the stock, I guess, steering, was that it liked to flip sideways or backwards and forwards, because this motor right here that I put in is very quick. So something that I might add to this is an extension of the wheels, so they come out much further, maybe a centimeter and a half or two, both ways, so that the car has less chance of rolling over. One negative part about this is the arm that I will be using to steer. If I do 3D print it, it might become quite weak. The servo will also have to push more, but also if I did do that, I would have more turning and less of it gripping right here. So I think I might implement that, fix these bad boys, possibly increase these holes by a few millimeters. This does fit very nicely, much better than it was when it was inside the toy. Increase these holes even. Oh no, now they're getting pretty soft, so maybe I won't. These ones right here can be drilled out. They didn't come out very nicely. But besides that, oh yes, and then I need to put the space for the steering. But besides that, I think it's a very good first prototype. I'm quite proud of it. This is the first time that I've come up with an idea, drawn it, designed it on CAD, and then 3D printed it. So even though it has not worked out the way that I wanted it to, every failure is something that you can learn on, and I wouldn't even consider this a failure. This is definitely a win for me. Coming from a print that was quite bad. I mean, this little benchy right here did not come out very well, but I started playing around with the settings on this extension right here, did a bit of research, found out that some characteristics the PLA has, you need to change the settings, so that's what I did. And this is quite small, so it took about 2 hours and 10 minutes, I think, to print the parts. Even the, like I said before, I thought I might needed to sand it. It just fit in perfectly. I might not even need the screws, it's so perfect. So yes, I'm extremely proud of this, and I will make an update as soon as I make version 2.